So hello guys, today we are going to solve a Leetcode question that goes by the name nth Tribonacci number. You must be heard about Fibonacci. What is Fibonacci? Okay, Fibonacci is basically the sum of last two terms. So Tribonacci is basically sum of last three terms. So the current term that should be there would be the sum of last three terms. So basically that is what it is saying. So you just have to find the nth term of the sequence, nth term of the sequence. Okay, but what does it mean by I mean by sum of last three terms? Basically, suppose if your three terms are like this, 1 1 1, so the next term would be 1 plus 1 plus 1. So the term that would come here would be 3, because it is the sum of last three terms, like this. Okay, so this is what I mean by the Tribonacci term. So what we are given with this, suppose basically I have to calculate this one, this index or this index or this index. So I cannot calculate these, so this should be given to you. Because see, if you are trying to calculate the last three terms, just open a calculator. Suppose you are given with this, you have to calculate. If this is your fourth term, this is your fourth term, so it is the sum of last three terms. So what about these three terms, because if you see, uh, the three terms before this index are not there, so these three terms should be given to you, this and this. And after that, any other term you can just find it out. Okay, so it is as simple as it looks. This is just basically, if this is 0 1 1, so it is basically 0 plus 1 plus 1. So this term would be 2. So if I come to this index, what this term would be? It would be the sum of last three terms. So 2 plus 1 plus 1. So 2 plus 1 plus 1, 4 exactly. And what about this? 4 plus 2 plus 1, so 7. Okay, uh, I'll come to this index. Sum of last three terms, 7 plus 4 plus 2, that is 30. It is as simple as it looks. So this is what the question is saying. The Tribonacci series sequence Tn is defined as follows: T0 is equal to 0, T1 is equal to 1, T2 is equal to 1, and Tn plus 3 is equal to last three terms, Tn plus Tn plus 1 plus Tn plus 2. Okay, so basically it is saying that any nth term would be basically Tn minus 1, Tn minus 2, and then Tn minus 3. Okay, it is written like this. Basically, if you just add plus 3 to all, it would be in the same format. But why to complicate things when you know how to deal it with them in the easy way? So this is what you are given with. What you have to do is basically uh, find the nth term, and this would be the formula for your nth term. Just remember that zeroth, first, and second term would be given to you, because see, 2 minus 3 is minus 1. Okay, so it would go to minus 1 if you just want to calculate the sum of this. So minus 1, index is nothing, index minus 1 is nothing. So you will be given with these terms. And in this case, what are these three terms? Basically it is given that t0 is equal to 0. Okay, so 0 term is 0. Then first term, what about first term? T1 is equal to 1 and T2 is equal to 1. So 1 and 1. Okay, so these are the first three terms that are given to you, and you have to find the nth term. Just let us see the constraints. N is till 37, n is till 37. So it is quite easy, because n is till 37. Just to try to remember, if you go by the recursion approach to find the sum of n Tribonacci series, it won't work. Why? Because see, uh, basically you will have n raised to power 37 combinations. So 3 raised to power 37 combinations, basically this number of operations will be performed, and it is not possible to perform such operations. So many operations it is not possible to perform on an online compiler. Okay, so this is the limitation. So we'll directly jump to the solution. How we'll solve this? Okay, we'll solve it by dp 1d dp. What is dp? Dp is basically dynamic programming. It is used to solve overlapping sub problems. Okay, so let us try to see what happens. Suppose you have to get the sum of n is to 5, n equal to 5. So you have to get the sum of the fifth term. So if I just write it down, 0 1 2 3 4, and then fifth term you have to get the sum. You have to get it till n is equal to 5, or we'll just take a test case n is equal to 4. Okay, n equal to 4 you have to get. So this is what you have to get to. N is equal to 4. Okay, I am given with these terms 0, 1, 1. Okay, so what I have to find out? I have to find out. Just see how you will be using DP. Just see if you just try to iterate and at every index, what you just try to do it. What you just try to do, if this is my DP array, this is my DP array. So every index would be like DP of I is equal to DP of I plus DP of I minus 1 plus dp of I minus 2. It is very basic, right? I minus 2. It is very basic, right? I minus 1 minus I minus 2 and I minus 3. I'll just write it down again. See, this will be I minus 1, this will be I minus 2, and this is will be I minus 3. So every term would be like this because this is what is given. See, in the question only they are saying like this. T n a term is basically the sum of this plus this. Basically n minus 1 term, n minus 2 terms, and n minus 3 term. So if you just come to this index, what is the sum of my last three terms? So 1 plus 1 plus 1. I'll just store it at this index. So it would be 1 plus 1 is equal to 2. Okay. I'll come to the fourth index. I'll come to this index. I'll apply the same formula again because you have to just, this is just given to you. This is given to you. You are doing nothing. Basically, not, it is just given the name DP. It is not DB. You are basically doing the stuff you want to do. So you are basically making an array, and we'll make the array of size 38 because the max constraint that is given to us is 37. So to be safe, we are making it 38 to be on the safer side. Okay, you can make 37 also. I'll make it 38. Okay, it is not wasting an extra space. Like one space is nothing. Maybe nothing. Depends. Okay, so I'll come to this index. What I'll try to do is try to find the sum of last three terms. So I'll just for this index, what are the last three terms? Basically 1, 2, and then 3. So these are my last three terms. So 2 plus 1 plus 1. 2 plus 1 plus 1 is equal to 4. Okay. So here comes the solution. The term at and then after just modifying the array, I'll just return dp of n, and this would give me the answer. This would give me the answer. Okay, so dp of n would be automatically modified such that it would contain the answer because see, you are adding the terms all together. See, till this you have already added, now you have gotten an answer, and for this also you are just adding all the three terms. So at every index you are just storing the answer. This is my answer for the fourth term, this is my answer for the third term, this is my answer for the second term, this is the answer for the first term, and this is my answer for the zeroth term. So this is what you are given. But just try to, so I'll just return at last what I'll return. I'll simply return dp of n. Okay, and I'll do this till, basically I'll do this till my n is till my n, basically I'll run the loop till I is less than equal to n. And what is the index that I will start from? Yes, 3. Why 3? Because see, if it is not starting from 3, all the other answers are already given to you, right? All the other answers are already given to you, so there is no need to worry. Well, basically start from 3, and if you just start from 2, it would be going out of bounds because see, 2 minus 3 is equal to minus 1, so it would be going out of bounds. It will give a runtime error. So I'll start with index 3 and I'll go till n, and at the last I'll return dp of n. dp of n would be containing my answer, obviously. I'll just try for 25. I won't try because it will be a very big number. I'll try for n is equal to 5 or n is equal to 6. Let's try for n is equal to 6. I'll just make a array such that it contains the index 6. Okay, so basically you cannot make a 37 size array because see, uh, for n is equal to 37, you will have to get 37 indexes, and for that you will have to see from 0 to 37. So it would be of size 38. So 38 would be the best size to get, best size to take. After this you can take anything like 39, 40, doesn't matter. Don't waste so many space, just make it 38. So I'll make one more. So this is what I'm given with 0, 1, 1. I'll just iterate from the third index. Okay, what I'll do is dp of I should be equal to the first last term, basically the last term, the previous term, the second previous term, and the third previous term. So for this index, what are my last three terms? 1, 2, and 3. 0 plus 1 plus 1, that is 2. Okay. I'll come to the fourth index. What are my last three terms? Basically this, and this. Okay. So 2 plus 1 plus 1 is equal to 5. Okay. Seems nice. Seems easy. Okay. I'll come to this index. What are my last three terms? 1, 2, and then 3. So 5 plus 2 plus 1 is equal to 8. Okay. Seems nice. Seems nice. I'll come to this index. What I'll see, last three terms, this. So 8 plus 5 plus 2, that is 15. And at last, what I'll return? dp of n. So dp of n means dp of 6. So that will be returning my answer. Yes, 15 is my answer. Okay. I'll try to code down the approach for you. What I need, first I'll need a dp array of size 38. I'll initialize all of them to 0. Okay. Then I'll explicitly define that my dp of 0 is equal to 1. dp of 0 is basically 0 because if you are given this, t of 0 is equal to 0. Okay. And then dp of 1 is equal to 1. dp of 2 is equal to 2. 2 is equal to 1. This is what you are given with. Okay. I'll start with the loop. What is the index I'll start from? 3, because before 3, if I go, I'll go out of bounds because 2 minus 3 will be gonna be minus 1. So this is not a, this will not be an optimal approach to go for. So I is equal to 3, I'll go from I is equal to 3 to I is equal to n, less than equal to n. What I'll do is, I'll simply use the formula dp of I minus 1 plus gp of I minus 2 plus gp of I minus 3. And at last what will return? dp of n. This is as simple as it looks. It is very simple. Very simple. So I'll try to run it. I'll try to submit. Let us see. Okay, submitted successfully. So I'll just try to explain you the code. Basically, this is what I am given with already. This see, t0 should be 0, t1 should be 1, and t2 should be 1. So this is what I am just writing. What I'll do is I'll go from the third index to the nth index. I'll just traverse the nth index also so as to get the answer. And what I'm doing at each index is basically I'm summing up all the terms. Basically for the nth term. For the nth term, I'll go to n minus 1 plus n minus 2 and then n minus 3 also. I'll see all the three terms. So I'll just repeat this, and if you will see, you will eventually get the answer. The nth term will contain the answer for the nth term because basically you are just following the series, and at last you just return your answer that you want. Okay. So what is the time complexity? As I'm traversing only once, my time complexity is gonna be O of n. As I'm traversing only once, my time complexity is gonna be O of n. Is there any extra space? What is the space complexity? Yes, I am making a DP array. So my space complexity is gonna be O of n. So we have done it in the time O of n time and O of n space. And if we have went to the recursive approach, we will have a time complexity somewhere close to 3 raised to the power 37. I don't have time to make such perform so many calculations because the online compiler doesn't allow me to do so. So 3 raised to the power 37 is avoided by dynamic programming. So this was all about the question and Tribonacci number. I hope you guys enjoyed it. It was a variation of the Fibonacci series of Fibonacci number. Anything you can say. So I hope you guys like it. If you have any doubts, just ping it down in the comments. If you like the solution, do like, share, subscribe. Thank you. Have a nice day. Bye bye.